In the last video, you looked at the nature of waves and wave properties. And in this video, you're now going to look at specifically electromagnetic waves. You will be introduced to electromagnetic waves, the different types of them, and then how we organize the different types of electromagnetic waves based on their properties, so based on their wavelengths, their frequencies, etc. Let's start by defining electromagnetic waves. Electromagnetic waves are waves that can travel through matter and space. So there are electromagnetic waves all around us currently. Our atmosphere filters out some of the electromagnetic waves that travel through space, but ultimately we use all the different types of electromagnetic waves that we will look at next. We will start looking at each wave by their wavelength. So to begin with, we'll start with radio waves. These are the longest waves. Their wavelengths are the size of football fields, even the size of mountains and buses. And after that, we move to microwaves. Microwaves are between the wavelength of 30 centimeters to 1 millimeter. So we're looking at, the size of a bead, the size of a pinhead. Infrared waves have wavelengths between 1 millimeter to 750 nanometers. So we're now at the size of a cell and bacteria. Moving on to visible light waves, our rainbow of light that we can see, that has a wavelength between 750 nanometers to 400 nanometers. Moving on to UV or ultraviolet waves, which can burn your skin, is wavelengths between 400 nanometers to 10 billionths of a meter. And then we move on to X-rays, which are the size of atoms, and then on to gamma rays, which are our smallest wavelengths, which are the size of nuclei, so really small stuff. You learned in the last podcast video that frequency is the number of wavelengths that pass a fixed point each second. So if we have long wavelengths, there are going to be less of them passing a fixed point in a given second compared to short wavelengths, where we have more passing a fixed point in a given second. So our long wavelengths, radio waves and microwaves, have low frequency compared to our X-rays and gamma rays. And now we'll look at the relationship to energy. So our short waves with high frequencies, such as our X-rays and gamma rays, they are the most energetic electromagnetic waves. So the short wavelengths with high frequency have high energy. Conversely, our long wavelengths with low frequencies, such as our radio waves and microwaves, have less energy. So as the wavelength shortens, the higher the frequency and the higher the energy. Conversely, as the wavelength becomes longer, the lower its frequency, the lower its energy. In this podcast video, we talked about what electromagnetic waves are, that they are waves that can travel through space and matter, and how they're organized into the electromagnetic spectrum based on their wavelength, their frequency, and their energy.